Hey everybody, this is Larry. This is me doing the weekly premium problem. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, even if you don't have premium. Okay, so today's problem is 651 4 keys keyboard. Okay, let's see. We have a special keyboard with the following keys: A, select, hold, copy, and then print. Print buffer on screen, appending it after. Say what? And then we try to max. Okay, I mean, that's fine. But print buffer on screen, appending it after what has already printed. Let's see what they mean. AAA, select all, Control C, and then VV. So then now we have, okay, I mean, I guess I get it. And N is at most 50. Okay. These ones are always kind of tricky. I think there are a couple of strategies you can think about it. This is either, there are two things I'm thinking about right now. One is dynamic programming. I have to figure out what is the best way to dynamic. I don't have one ready yet, to be honest. But we can kind of figure it out. And then the other is kind of just like one, or manually using a notebook or something like this. Run it for small cases and then see if we could get a pattern really quickly. I'm going to try to do this with dynamic programming just because it's 50, so it should be straightforward in terms of like not needing, because if N is like really big potentially, then maybe dynamic programming is a little, depending on the constraints and how the expense, how expensive it is to dynamic program. It may not be what you need, but here N is equal to 50 should be okay. Because sometimes some problems, and maybe not this one because it's Leetcode, and I don't think they do that quite yet. But if you do like other competitive programming, like on I don't know, like Codeforce, for example, sometimes these are kind of like, okay, here's a thing, you have to kind of get a pattern and then derive some formula that is almost O of 1 in general or something like this, right? Something to that level. I mean, it doesn't happen that often either, just to be clear, but these are things that are going in my head just to kind of tell you what's up. Yeah. Okay, so yeah, let's try, right? So basically, we'll just see how many, in theory, the way that we'll want to do is, right, and then maybe presses left is how I would do it, and obviously presses left would have at most 50 different things, right? Because that's the constraint. So then now what can we do with one press? Maybe there's a different state. Let me think. I mean, maybe I'm wrong on this, by the way, so let me think about this. Almost want to say maybe I'm a little bit wrong now that I think about it, because it's not just the presses, it's about how many things you have screened right now, right? And how many things are on the buffer right now, right? I think for this one, let me retract this. I don't know if I know how to get dynamic programming for this. I was thinking a little bit. I might have misunderstood this one a little bit. So okay, oops. I think this is also one of those things that that are either base 2 or base 3 or something like that. That's why I'm like, you kind of like, if I have to guess, maybe it's like n over 2 to the 3rd power or something like this, right? Something like nuts, or n over 3 to the 2 power. Something like this where like you have some maybe pattern or thing, right? And and that's just like off my head, kind of like that's the kind of thing that I'm thinking about. I don't even think that's like, I don't have like confidence in that exact formula, but something like something of that texture, something of that feeling, and maybe some of that is just experience. But yeah, if n is equal to 1, then f of 1 is just going to be equal to 1, right? I mean, you only have one move. F of 2 you're going to have 2 because you just print it twice, right? So f of 3 is 3, and same thing. You print it, and then 4. What is 4, right? 4, can you divide it by 2, right? So you have 1, you copy, you paste. That's only 3. So you're going to write 4 twice. Write A 4 times, right? And then f of 5, what is it? 5 So you do it 2, you copy. Oh no, you have to copy. You have to select all and then copy and then paste. So it's not just. I think this actually reminds me of like an n squared type thing. Because basically you're trying to balance. Is that true? Maybe that's not true. Hang on. I mean, I think the other thing that I was saying, and I think I said it wrong. I said n over 2 to the third or something. But what I actually mean is like something like 2 to the n over 3 or something like that. That's what I mean. Now that I think about it a little bit. But I think that's what I meant in the beginning. But I think I just kind of messed up in my head. Because... So my second strategy was something like, you know, A, and then you do a Control A, and then Control C, and then everything after that is Control V. But that doesn't make sense because, in a way, if you have enough moves, you know, for example, maybe it makes sense to do another one here, right? Like we do, we Control All, and then Control C, and then do it again. Then that basically doubles this twice, in exchange for 3-fold type things, right? So that's kind of. So there feels like there's a divide and conquer thing. This is only a medium. Am I making this too complicated? I don't know. This is why I don't like having the difficulty, because sometimes like I don't know. Now I'm like second guessing myself everything. All right, let's figure out for 5 first, right? What's 5? So 5, we can obviously write 5 A's. We can write 3A Control C. Well, you can write 2 A's Control C. Oh, sorry. Take 2 operations and then Control V, and you only have 4. So still write 5 A's. Just write 5 A's. Right. What's f of 6? So let's do it. And then series, you know, something like this. What does this mean, right? This is, it takes 2 operations to do a copy onto the buffer, and then paste. I think now I get it a little bit better, and now I think I can maybe dynamic program, but maybe that's not true still. But that's going to be 6, right? Yeah, this is going to be 6 in both ways, right? Right, 6 A's and also that, right? And then f of 7 is 9 because of, you know, it's an example. I'm thinking about different greedy-ish strategy as well, in terms of like, okay, in terms of maybe we can brute force the number of A's, right? Like that's just one thing that I'm thinking of. I don't know. And what I mean by that is you can say, okay, how many A's can we get if we write 1 A and then use Control V, Control A, whatever for the rest? How many times would we use 2 A's and so forth, 3 A's and so forth, right? So, you know, for example, for f of 8, what is the answer here, right? I think right now I'm just trying to get an understanding in general. So we know that we can do at least this. So basically this is going to be another 3. So this is just 12 over the last one. All right. Can I express this in terms of the previous functions? Right? I think that's the tricky part. And I don't... So I have a dynamic programming idea in my head, but honestly, I'm not sure that it is bounded. That's why I'm curious. So that's why I'm hesitating a little bit. This is going to be 12, but can we do better, right? Let's say we have 2 A's. How does that work? AA, CA, CC, CV, and then CA, CC, CV, right? What is that? That's 2 doubles, 4, and then 8. So that isn't good enough, but I'm just trying things. I think one pattern that I'm thinking about is that I mean, because that isn't good yet, but then now what's f of 9, right? F of 9 maybe it is then, right? Because in this case, this would be, so now we double twice, so then went to 6, and then I guess this is 12, so it's still not yet, because it's going to be 15 if we, well, this is 12 because we double twice, but if we do it just like f of 8 plus another CV, that is going to just be 15, right? So, but I think like there is a pattern is emerging, but I'm really slow on it, perhaps, because, but basically the idea is that if you double, you want to, you're going to use X amount of CVs, and it only makes sense to, let me try one more thing first. Let's say we have 4 A's, right? What does that mean? That means I have CA, CC, CV, CV, CV. So that means that we did 4. So this is also 12. So this is still no bueno. No, this mathematical thing is hard. No, yeah, I wonder when is it. Because I think it never makes sense. Because I think there is a case in which it makes sense to have 4 A's at some point. Because that's fine. And even 5 A's. But 6 A's never makes sense because you can always just use this sequence and then you could double more or something, right? Or just copy and paste the same amount. So this is one way to get 6 anyway. So it almost never makes sense to, or like equivalently, it doesn't make sense to have more than 6 A's, right? And given that, can I brute force it? Let's say we're only trying 1 to 5 A's inclusive. How many branches are there, right? Because basically at every point we have really one decision after the A's, and it never makes sense to write an 8 after the initial A's, because then you, by, it's not commutative, but if you just move the same A to the front, then you would get way more benefit. So the A's all have to be in the front. And then it becomes 3 moves to double. Okay, I think I have an idea on brute forcing, because basically the other idea that I have is that you always want to double in the beginning, right? Because also by I don't know. I mean, it's not, maybe it's the exchange argument, kind in a way, not quite maybe, but in a way, it's like the exchange argument of, okay, if you could double before and then paste more, or double afterwards, of course you're gonna double in the beginning because you just get more. So that means that we can brute force on the A, the number of A's up to 6 maybe, and maybe we'll just try more just because I'm not 100% sure on that one, and then we brute force on the number of doubling, each taking 3 steps, and then the rest of that will be CVs. So that's always going to be the sequence as I will understand it. Whew. This is kind of, I mean, maybe there's an easier way to be honest, but I feel like that's the way that I'm going to try to code it up, and then we'll see. Okay, so for, I don't know, whatever, this of Yeah, okay, fine. Oh, it goes only up to I. Oh, no, 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 that's not true. It goes up to... Yeah. It goes up to, whatchamacallit. Well, you need at least one of these. Otherwise, it just doesn't make sense. Or like, you know, you're pasting emptiness, right? So you need at least one of these. So then, yeah, I'll write this as a while loop. J is equal to 1, right? While I plus 3 times J is less than or equal to N, then we do some things and then we increment. Okay. And J is the number of doubling. I's are the number of initial A's. J's are the number of doubling triplets of CACCCV. And then, I don't know, I guess K's are or number of series. We didn't do K yet, obviously. But yeah, okay, so K is equal to the number of moves left, which is going to be N minus I minus 3 times J, right? And then now the math for that is going to be, I have to put it best. So best, we just, you know, set it to N in the sense that this is going to be all A's, right? I think this gets covered anyway, but so basically the current score, let's just call it that, is just equal to, okay, so we have, let's start this at 1, because I don't know that it makes sense to have 0 either. Okay, so now we have I's. We have I, and then for every J we double, so we times it by J, or 2 to the power of J, right? And then we added, we add, okay, let me think about this for a second. 2 to the, so basically this is the last thing that's on the buffer. Wait, give me a second, sorry. So let's say J is 1. Yeah, okay. So I tried to do it in one move, but basically what I should do is J minus 1 is the number of doubling, right? So this is the last paste, or this is the paste size, right? Because if J is 1, then the last paste size is I. Okay, yeah. And then score is equal to I plus the last, this last thing is messing with me a little bit. No, I think this was right. Plus last times K. Something like this. Also put parentheses in case. Alright. Give it one real quick. Something's a little bit off. So if we have one double, or if we have 1, then it doubles. So if this is 1, then this doubles. Yeah, that's right. What am I getting wrong from? Let's see. Easy to print out everything. Look. Okay, so we have. Oh, I didn't reset some stuff. No, that's not true. What? So 4. We doubled it once. Did I mess something up? Probably. So K is 6. That's not right. Right? We have 4. This uses 1, and that's already 7. Did I mess something up? Oh. Why is this minus? That's the number of moves. Yeah, okay. All right, so that looks good for this one, but that doesn't mean it's good. Luckily for us, it's a small test case, so we just won 50. Wrong answer, so that's not good. But at least we kind of figured something out. Maybe. Is that... Actually, there's a better answer, huh? So maybe my greedy was wrong. Wow. Let me think. Did I at least get 9 right? I don't want to... So, I mean, I know that I already kind of cheated by using 50, but at least I want to do the one that I know the answer to and just look at my code for it. So 9... Oh, it's 16, so actually my thing was wrong. How do you get 16? Oh, I did this math wrong. This is 16, yeah, whoops. So already with 4, you want to do 4. That gets it? Yep, I mean, I guess that's fine. But apparently there's a better answer, huh? I mean, pretend that I probably submitted this. I do wonder if my hypothesis that there are ever going to be 6 A's will ever be true. What's that? Where's the 204 from? Let's see. Yeah, with 5. The last one. Then we do 3 copies. That doesn't make sense. Does it? Oh no, because we use one more for doubling. So then do we always want 3 copies? Is that it? I don't know how. I mean, this is as brute force as I think I can get. That's why I'm like a little bit awkward that it doesn't work and that you can do better. And I'm missing like a real way of doing it. I've been going on for 22 minutes now, so that's actually Is it DP? Man, I am really off on this one. Double 16 times and then do 1K. What are the sequences that, let me get that? I thought I knew this one, so that's actually pretty bad. But we can actually also check, right? So 3, 1, and 3, which is this one, is 15. So this is right. 3, 2, and 0 is 12. So but I mean, am I wrong in some case? So there are only really 2 things that I thought, greedy wise would be true, which is either putting all the A's in the beginning. I feel like that part is true. And then putting all the doubling in the beginning. Oh, maybe not. Maybe that one's the wrong one. Because I think that maybe you could double. No, because I was going to say we could double copy and then or double paste and then double. Why is that? Why would that be different than doubling and paste? Is my math wrong? Basically, I'm just trying to think whether you want to do this plus some last number and then times 2 versus times 4 plus the last time we paste, which is going to be, if we paste only once, then it's going to be essentially times 8, right? What if we have 2 things left? What if we could paste twice? Do we... I mean, I think the right way to do it, in light of these, is just coding it. But I'm also trying to like think if it makes sense. So the I, J, and K is going to be right, but maybe there's the different ordering. Maybe there's something. Let's see, right? So basically, let me just prove force saying, okay, let's say this is the way to do I's. Actually, we could even just put it here. And then J's, but the before last. Before, I mean, you can also add another like O of N loop to kind of brute force when you put in the 2 or whatever extra K's. But now I'm thinking, like, if that's wrong, what if you just like interverse them? Man, this is hard. Or maybe I'm just missing something obvious. Let's kind of. Let me try to do it with the brute force way, maybe. Well, not brute force, but just kind of dynamic programming brute force. What would that look like? So what I would say, let's just go. Man, this is a mess. But let's just say get max of presses and maybe buffer size, right? So then now we want to return get max of n, and then the buffer in the beginning is 0. And then basically we have a few things that we can do. We can just press A, right? So A is equal to get max of, we pressed 1, and then buffer doesn't change. Oh, sorry, presses +1. And then we get 1 in the final thing, maybe. Is that true? Is that the way that I'm thinking about it? Because you need to also find count A, right? Maybe, and then beginning is 0. But that feels very expensive. Maybe that's the way. Maybe I just overthought it. Maybe there's not that many states. I don't know. But the thing is that the buffer can be a unbound number. That's why I'm like. Yeah, that's why I'm kind of confused. But okay, fine. There's 1A on the screen, right? Oh, sorry. Count of A plus 1 in this case. You can also do Control A, Control C, and you need both of them because it doesn't make sense to do either without the other, right? So presses was 2, count of A is the same, and then buffer is equal to count of A, right? No, not. Yeah, count of A, right? And the score, the number of A's didn't change, but that's just that. And then now CV is you're gonna get max of presses plus 1. We have count A, actually count A plus the current buffer. The buffer doesn't change, but the number of A's changed, and then I guess maybe I don't even need count A in that case. I can just or like I don't need the plus 1. I think it becomes almost like a search problem. But count A could be really big, right? As we saw, it could be 1 million, right? So 50 times 1 million isn't going to cut it. But my recursion isn't even like, I feel like I'm just off. Right? Okay, fine. If presses is equal to 0, oh, I guess I counted the other way. Whoops. we return count A, right? I think that's fine. And then this is if presses -2 is greater than equal to 0. The other one should be fine. This will time. Oh, I thought maybe it would time out, but it doesn't. That's actually surprising. Okay, yeah. And now we just kind of do the magic cache and then see if that actually terminates. I'm actually curious about I'm not convinced that this doesn't time out, to be honest. But I think why I implemented it anyway is because I want to run it for small ends. So then now I can maybe learn from it. Like obviously we could have done it as well, but that's kind of cheating, especially like on a contest, you will not be able to get the answer, right? So you know that you don't know the answer. Oh man, I forgot to take out that case, the 50 case at least. How do I take this out? Or is it because it's running? Okay, fine. Okay, there we go. Yeah, memory limit exceeded, so that's not great. Okay. So basically 10 is 20. I'm also trying to see like what limits can we push, and then we can. So at least now I am more confident that our code is correct, but it's not fast enough. But that's why I kind of worried about it. That's why I didn't do it this way for a while. Even 30 is very good. I think one thing that you can do, so now that we have this, and obviously it's not a full answer because like I said, it's 50, right? What we can do is actually, oh my God, I can't believe I'm doing this. Half an hour in, I guess. What I want to do is do I want to do this? Well, what you can do, and I don't know if I'm debating it now, and if you're still watching, thank you. But I'm trying to think. Oh yeah, what you can do is path reconstruction, so you can kind of see what is the like for 30, what is the best answer, and yeah. But do I want to do that? We'll see if this kind of works for now. Maybe 30 is too much printing. Oh, actually, pretty okay. Well, not okay, but... Yeah, this is useless. No, I mean, I was hoping, but... Fine. How do I want to do this? Okay, fine. So this portion is going to be less teaching. It's me going to try to figure out if I know how to do it, to be honest. That's not true. That's not what I'm trying to do. Sorry, I'm not explaining too much. I'm really my throat actually kind of hurts a little bit. Let me try to debug this and try to figure it out if I know an answer. And I mean, I don't know. Maybe I'm just, this is just one of my kryptonite, maybe. But yeah. But clearly, I don't know this enough to explain it. So let me try to get it. Okay. Right. Okay. Yeah. Okay. Man, I really don't know this one. I mean, maybe it's greedy, and greedy ones are hard anyway, so yeah. That's my excuse. Okay, so AAA, yeah. AACAC, AAA, Does that make sense? Did I print something wrong? Why would this ever... Okay, so you have three, you take all your copy, but you never paste. You have to paste. Did I just print the wrong thing? Huh. I find that hard to believe. I mean, okay, something is wrong with the thing, but... To the count of A. I guess is this backwards? No, it doesn't even matter if it's backwards or not, right? That's kind of weird. Where's this? Okay, you have A plus stuff. You have 1A, you have 3A. Oh, I think I did this a little bit, whatever, but okay, fine. It's okay. So you start with 4A. Was that the one that we're looking at? No, we're looking at this one. Okay, let's look at this one first. We start, so you have 3A. You copy into the buffer, but the buffer didn't get updated for some reason, but oh, then I traveled the wrong one. Which one am I looking at? This one. Okay, yeah, buffer is equal to count A is what I mean. Okay, it was taking the wrong path. Okay, yeah, AAACA. Oh no, CV is the. Oh no. Buffer. I mixed them up. CA. I can't look. What did I do? Why am I? Oh, because I did this in two different orders. I got them mixed up. I see. So count A is we added to the buffer on a paste, right? Okay. Alright, Larry. Alright. So AAACA. Is it still wrong? We copied to the buffer 0 count A. Oh, this is minus. Oh yeah, like I did everything. I mixed them up, the enums or whatever. All right, that's kind of sad. Okay, so this is what we expect. Yeah, okay, this is what we expect with 3, and then we okay. So much debugging the debugging. Okay, so 9 we have 4, so that's why it works. 30. Okay. paste, interesting. So the pattern that we want is actually a 4 paste, because then the first one is a doubling. But this is ridiculous. Oh, I see. So basically you want a 4 operation, not just a 3 operation, to double twice. How am I supposed to represent that? I mean, that makes sense, but I feel like I'm missing some underlying principle on this one. Is it always at most 4a? Let me see. Still 4a, but because we could double twice, and 4, like I thought 4a was a good thing, but yeah, I mean, and the extra one is the one before the last, maybe. That makes sense, because this extra CV, does it, Larry? Does it? The extra CV makes it like, so this doubles and then this triples. But if you want to quadruple, you might, I don't know. I don't know that I know this one. I feel like I'm missing a principle here. Let me also just print this, maybe. Oh, not this. Let me print. I just want to see like the size of the cache a little bit. Like, can we optimize this for 50 and then go look at the answer or something? Because I feel like I don't know anything. And these numbers don't make any sense, really. So 35 already has 400, so that's already a lot of states. And I feel like that's the thing, right? Like I feel like I could like code this up like as part of this in a way. But I just feel like that's so ad hoc. I feel like I'm missing something like simpler, like some underlying thing that I'm trying to figure out if I know how to figure out how to do it in a easier way. Or am I just stubborn and not, you know? If you have 4, do you always times 3? Is that what you want? Let's say we keep on taking all the pairs of 4s. For example, how many things can... Well, I guess, I mean, if you put them in groups of 4s, then you always, at most, it's going to have 3 things in the back. So if you want to do brute force on that, I guess group of 4s are kind of what we want. And then okay, 7 is the first one, I think, of a group of 4. Maybe that's why. 6 is Gucci. What is it? 8. All right, let's focus on getting this right, and then maybe we'll I don't know, see if there's an easier answer. Okay, so if n is less than equal to 6, we just return n. Fine. I mean, we wrote a lot of code. I knew that this wasn't going to probabilistically work, but I just want to write this to explore the problem, right? And sometimes, you know, you have to do what you have to do, even. But this gives us a lot of insights, right? Now, whether we get it still wrong is another story, but yeah. So this is 7. What do we have? An 8? No, we have a 9. What is 8? Let's see. We have 8. I mean, actually, I mean, I did it this way and it was fine, but apparently you could have also done it with Okay. So basically now you have groups of 4, and after 7 it's always going to be so. Okay, so if n is equal to 7, just return 9. One other way that we could have done it is, you know, given this memorization code, we could have ran it offline and then kind of just returned the array. I actually was thinking about that, but I wanted to, I don't know if this way is much cleaner, so maybe that's a bad idea. But yeah, so basically, okay, we have 4 A's, so count A is equal to 4, n subtract by 4, right? And then now we have groups of 5s is equal to n mod 4, because that's just the number of leftover, and then 4s is equal to n minus 5s. Wrong order, obviously. Yeah, and then basically we double 4's time, so count A, we double, right? And then for each 5, we oh no, this is wrong. For each 4's, we copy paste, so that's double, and then the second one, so we actually times it by 3, and then otherwise for 5's we times it by 4, and then we return by count A, right? Okay, this is wrong universally. Why is that? Okay, because for this one, what is 9 again? 9 is, let's do the 8 first, because 8 is 4, 4, right? So 8 should be just 4 times 3, right? Did I mess this up? I mean, obviously I messed it up, but oh, this is, I'm dumb. So the 4 should be groups of 4, and the 5s, well, the 5s are just a number of 5s, and then 4s should be 4 minus 5s, I think. Yeah, I am dumb. I forgot to group them into 4, actually. All right. This is also what I meant by like this pattern finding thing, but and sometimes you use the machine to help you, but okay, this is still wrong though. Oh no, we have it all the way. Is there one where this is? Wow, I mean I am stumped. Unless they're like 4s and 5s. How is that possible? 9 tripling and but this is actually the intuition that I was talking about of actually it's kind of funny because right at the very beginning I was like, oh, it's gonna be like n over 3 to the power or 3 to the n over 2, or something like this, right? And this is kind of mostly very resembled to what I actually expected to be, but it's a little bit off obviously, but I'm still kind of like, you know, that's what intuition buys you, I suppose. It is wrong for this one, which is very sad because my DP is not, you know, good enough. Is it at least good for these? Okay. Oh, it's wrong for 45 already, or 40. Can I run 40 real quick? Oh, I left in the 45 accident. That might time out. Okay. It might still time out, to be honest, but I want to see what is different from our thing. Do I not return this way? Oh, because maybe oh yeah, because I muck up the A N. I think I can just add back the N. Okay. Hopefully that doesn't time out. If it does, I don't really have a good idea of how to do it. Okay, so 4 groups of 4, 5s at the end. Ooh, 5s at the end. 1, 2, 3. So if this is 0, then it may be better is to okay, fine. That is such a and 4s is greater than or equal to 4, then 5s is equal to 4 and 4s is that even? I don't know. That doesn't solve it. Oh, this has to remove. Something is a little bit off, but because you don't get. You remove one group of 4 to get 1, 5. Okay. No, that's just. What am I doing? Okay, well maybe I just said n back to n. Maybe that's fine. Well, in this case, yeah, maybe that's fine. Let's see. Still wrong. Oh my god. So if we don't do this, this is just very wrong, right? On the other direction. Yep. But we know that we have 4 5s, but we're just doing the 4s count wrong. Okay. So 5s is equal to 4, and because of that, but this is way overcounting. So maybe I need to do -1 more. There's 4 of them, so okay, that math checks out, but this is such like ad hoc thing. But this is also the type of thing that oh no, still wrong. So that there's something like I don't know how to. I mean, I mean, we could brute force this, right? For the number of 4s and number of 5s, but it's just like at some point it's like, oh man, we're really, you know. I don't know. I think I'm gonna give up. Like I feel like we're very close. Okay, fine. Maybe I won't give up. I will just do what I said and just hash this. I don't want to do it, but it is what it is. I'm gonna run this offline. Hang on. Yeah, I'm gonna run this offline, and then I'll paste in the thing. You could watch me just hang out, I guess. I don't know. Let's see. I'm just gonna paste this code into something local. I don't really have local screen set up, but it is just the same code, and I'm just writing. Yeah, I'm just writing thing for it. Was it a dot max a? The good thing about this is that I think, can I cache this more aggressively? Yeah, it may be, but it's fine. I don't care to do it. And then maybe we'll play around. If this was a contest, I probably would have done this earlier just because I wanted to you know, finish quickly. But is it func tools? Alright, it's running. Give me a second. Don't know what we're up to actually. Maybe I should have printed some other stuff. Oh wait, I think I have to get rid of some code. Alright, there we go. Alright, the first 35 and 36 is pretty quickly. We'll see how the first 40 is done. Now that I did it, you know, now it's 41, 42. I mean, of course, you know, we know the answer. We have just ran it here, but it's fine. Hope everyone's having a good day. Hope everyone's having a good week and all this stuff. I'm gonna drink this delicious water. I've been fasting all week. Well, that being 3 days, but it's still a long time. And I'm just excited to like eating. Eating is exciting to me. 46. I wonder how. 46 has 6 million items. 47 has 8 million. That's probably why it's taking so long. Man, it really makes me rethink my relationship with food because I feel like I'm bored and then I'm just like eating and stuff, you know? Alright, 48 is done. But this is how you know, I think for one of the DM online judge contest won by Josh, the DMO the YAC contest, I believe. This was a technique that was required even for one of the game theory problems. So it does come up from time to time, and this is just like I don't know if it's considered recent, but like a couple of months ago, right? So I am curious to kind of learn the quote-unquote real way of doing it. I suspect that the people that are good at math probably have a deeper understanding of how these things divide, but I think I just kind of couldn't get it. I'm looking at the answer for like 49, and it has a lot of, I mean, I guess we could have brute force that way, like I said, but I just, at a certain point, like the math is, I don't know. But we're up to the n is equal to 50. So if that doesn't end, I guess, you know, we still can. All right, there we go. Alright, give it a submit. Yay, we did it, friends. But no, I don't know. I mean, I wrote code that solved it, but I don't know the answer for this. Let's see. DP. Man. Yeah, once we use the copy, there's no need to put aim because we can just paste the buffer instead. Yeah, I mean, that's kind of what I was. Maybe I didn't think of it that way, though, actually, but I did know. I mean, we did make that observation, so yeah. Oh, I see. I didn't know. I mean, I didn't know this, but I wasn't able to construct the DP from this. I mean, we could have done the same thing with brute force, really. I mean, I think the brute force would have been right, in the sense that where did I have it? Oh, did I delete it? Why did I delete it? The one with the count 4, count 5 thing. If you just brute force the number of count 5s, you would have been. It's basically the same thing. But I wasn't. I think the math was a little bit lazy for me, so I didn't want to try that. But that's a hard problem. Slash, I don't know. This is a medium. This is a medium. This is a medium. Huh. I think I try to generalize a little bit too much. I think if I had a base case that was more clear, maybe that would have been okay. Or rather, my states were not quite the same, right? Because I think the better states is kind of what they were talking about, which is basically this thing. But instead, because I think I try to, I don't know, do this thing. But instead, what they're saying is, okay, this is just not right then. But all right, let me get rid of some of this stuff. What they're saying is, instead of this, is that we have, okay. We don't have to, I think that was one of the minimization that I was trying to figure out, but I couldn't get. Right. I have a quick glimpse. I don't know that let me see if I can implement it so that I understand it, right? If press is equal to 0, that means we have no presses left, so then we just return 0. Otherwise, or rather, if presses is, I think that's the thing that we were, right? Like if presses is less than 6, we just return the number of presses. We did that table, so I think this is right? And then otherwise, well, we never need to do. So what they're saying is basically we want to do the copy and paste, right? Once this is get max of presses minus 3, and then we take this and then double, because that's just the number of things, and we copy and paste and double. And then we can also do another series, so we do 4 presses and then we triple, and then. I mean, I guess that's clever. I don't know. I mean, it is definitely a clever thing, but I don't know. I just didn't get it. Like, I mean, there's really no way around it, right? And then maybe even I don't know. I mean, maybe this isn't even necessary, but because in this case you can just double twice or something like this, and maybe that's better. I don't know, right? But that's basically what they're trying to tell you to do. Right. And then here, maybe more modifications of, because I'm too lazy to add the if statements. I guess I should test 50, but that's pretty cute actually. I don't know. I mean, some days, sometimes you just don't get certain things, I guess. This is a very long video. Hope you enjoyed it because, I don't know, I'm tired. I'm gonna go eat more things. Anyway, that's all I have for this one. Hope you learn from my mistakes. And I mean, it took me a while. I mean, I did get, just to be clear, like I guess I got an answer, even though it wasn't a solution that they would have wanted. And obviously in an interview, maybe hopefully you get a little bit of a hint and get it, even though we'll see what happens. But yeah, hopefully even if I didn't teach you this problem, hopefully you kind of look at how there are still ways to resolve it. And you know, there's the two ways that we solved it, at least, or could have anyway, already close to it. One is kind of just do it expensive and then do it locally in cache, and then print out the array like we did. And then the other one is, you know, we found the pattern, and if I had gone down that path, I could have gotten it, but I was just tired with respect to kind of, you know, like the count 5 thing. If you kind of brute force over it, that was basically it, really, which is kind of in a way because it never goes to 6, and it, for the most part, it doesn't ever make sense to even go to 3, but mine under like 7 or 8 or whatever it is. So actually, only these two things matter, and then in that way you can brute force the number 4s and 5s, and this, you know, the max input is n is equal to 50, so that actually would have worked. But I think I was just too like confused and whatever by then, and that would have worked, but I was just too, also like just didn't have that much confidence, you know. So yeah, let's see. Oh yeah, I mean, this is kind of vaguely what I was talking about. I don't know. And this is amusing, right? Because this is kind of, it's not quite what I said in the beginning, but it is an idea of what we said in the beginning. So yeah, anyway, that's all I have for this one. Let me know what you think. Let me know if you enjoy my struggle, because people always say they do. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.